Hey everyone, welcome to my YouTube channel. Today we are diving deep into one of the most underrated yet powerful concept in C Sharp, which is Struct with interface. If you are a C Sharp developer, you might already know about Struct as a lightweight alternative to class. But did you know you can implement interfaces in Struct to make them powerful while keeping the performance benefits? If you know, then it is good. If you do not, then I think let's get into the video. So in today's video, you will learn what is struct and how it works, struct versus class, stack versus heap memory, implementing an interfaces in struct, avoiding performance pitfalls, which is also known as boxing, and will provide you some advanced optimization like read only and using generics. Sounds exciting? So before wasting further more time, let's get started. So what is struct? A struct is a value type stored on the stack. Simple it is. Very simple definition. In C Sharp, struct is a value type, okay, that is stored on the stack instead of heap. Whereas class, which is a reference type, it gets stored on the heap. Struct is lightweight and does not require a garbage collection. So for example, a point. So whenever I'll be utilizing this struct, that means if I'm initializing the object of this struct, it is gonna get stored into the stack. So key differences here, some of them as I already told you, struct is value type and class is reference type. Struct cannot be inherited but can be implemented interfaces. So unlike the class, those can be inherited and we can do many things with the classes, but with the struct we cannot inherit, but we can implement the interfaces within struct. Of course struct gets stored on the stack and class stored on the heap, as I already told you. I'm keep on saying this stack versus heap memory. Before moving forward, let's understand the key concept of stack versus heap memory. So stack is fast and automatically managed, so you don't have to worry about managing it. Obviously it stores value types, it gets automatically managed, no garbage collection required. Whereas on the other hand, heap, it is slower than stack and needs garbage collection. So it stores reference type, obviously, as I told you. So as you can see on the line number, we are creating an object of a struct point. We are giving the values for x and y, so this will get stored on the stack. Whereas on the line number 2, person class, we are creating a new object of person class. The reference is gonna stored into the heap. Okay, so let's see this example real time. We'll create both of the we'll create a struct as well as class, and we'll see the difference between both of them. So in here, as you can see, I have a simple console application created here using .NET Core. Right now I'm using .NET 9. Okay, let me just close this one. So now we are going to create a struct. We are going to allocate some options here, not some options sorry, we are going to pass an object. So this is okay, so we have created an object. So p1 dot x is equal 5 and p1 dot y is equal 10. All right, now as you can see, we have created a struct here, and we have assigned the values for both x and y axes. All right, now obviously in the example I think I shown you this way, so let's do that way as well, the initializer way. So we'll just create two of them, new point. So x is equal 5 and y is equal 10. So there is no difference, both are gonna get stored on a stack. Okay, so you can just keep one way, I guess, no issues. Now what you can do is, let's say console.writeLine, And what we will do is we will just try to read the line values. So struct point x is equal, I guess, let's see, p1.x. Okay, and then y is equal p1.y. That's it. We'll run this application and we should see struct point. Alright, so that was my mistake. Alright, let me just rerun again. You see that the output is there. So I think this is how you can utilize this struct. And remember, struct always should be utilized for small operations, not for big operations. Okay, so this was the struct getting stored on the stack. Now we'll create a class. So let's say class person, public string, and just we are saying the name. Okay, and will be, so we're just saying here it is a stack. All right, now we'll create new person's object. So person and new. So now this is actually getting stored on heap. Okay, and we are not defining anything for the name, but let's just writing just for a test. We are just writing it. So class person name. Maybe what I can do is person.name. If we have name, then we will not here, sorry, otherwise we'll just display null. Okay, fair enough. So let's run. You see that we are getting null. That's right, because we have just initialized it, we haven't assigned anything. So let's assign okay, and run. Right, so this is the heap and this is on the stack. So this is gonna automatically get cleared when the main function ends execution, and this will require a garbage collection, which C# already does it automatically. You don't have to worry about clearing them, but you have to worry about when to use what is the when the struct is going to be beneficial, then utilize the struct. If the class is beneficial, then utilize the class. And remember, I'm saying again, struct is for lightweight operations. Next, let's see how we can implement the interface within struct. Okay, so as I said, struct can implement interfaces. It cannot be iterated. So just remember that. So this will be the example that we'll be following. We'll be creating a new interface, and we'll be basically implement that into the struct. Okay, let me clear this our earlier. Okay, so I'm gonna declare the interface right here, which is gonna be iPoint, and then we will have a method which is gonna return double, and we'll call it distance to origin. Okay, now I'm declaring a struct here. We will call it point. It is gonna implement iPoint. We will have, sorry, what is it? We will have an integer property here, which is gonna be we're getting it from the constructor of this point struct, and then public creating the constructor. Will receive x and integer y, and will be passing it to this should be small. Why it is automatically getting corrected? Oh yeah, sometimes this auto correction actually is pain in the ass. So this is still complaining because we have not implemented the interface yet. So let's go and implement the interface method. So public, of course it's double, and distance to origin. Okay, we are gonna utilize our math class here, square root x into x plus this will give us the distance to origin. Don't forget to return. Alright, all the errors are gone. We have successfully implemented the iPoint interface within the struct. Now you can see basically you can just create an object of this struct, let's say 510, okay, and console.writeLine. Let's call this the distance. Let's not be much fancy here. Let's just call the method distance to origin. Alright, let's run the application. See that, oh, we have got our result back, and using the using the struct. We haven't utilized the class at all, but we achieved our implementation. So this allows us to create lightweight structured data while ensuring it follows a contract defined by the interface. Alright, now next let's discuss about how you can avoid performance pitfalls like boxing. First, let's see what is the problem here. So struct value get boxed when used in interface based collection. So what does that mean? So that this is a big problem when using a struct with an interface, like, okay, so when a struct is stored in a collection of interface, for example like this, so you're creating a collection, a list of points. So now what happens is whenever you are gonna add new point within these points collection, this causes a boxing. Okay, so what's the solution here? So the solution is use generic collection instead, and this is how you can do that. So you can, instead of using an iPoint interface to define the type, you should define it generically. You can see that in here we are directly using the generic name of point instead of using the interface name. So this will avoid boxing. Okay, so this will avoid unnecessary heap allocations, because if you do this, so this is not it's not going to store into the stack at all, it is going to store into heap. Okay, so we call it a boxing. Alright, so next let's discuss an advanced optimization utilizing the read only. So we can optimize the struct even more by using read only. So read only, the reason of utilizing the read only is so there will not be any modification further after declaring the object of struct. So for example, this is the example that I'm explaining here. So what we are doing here, we are utilizing the read only keyword in front of struct. Our struct name is vector2d, and we have mathematical calculation going on here, just like how we did it earlier. We are calculating the magnitude, that is square root, utilizing the square root function. We are determining that. So why this necessary? It prevents the accidental modification, reduces the memory copies. let's see that in action. Okay, so I think we don't need this, or maybe what we can do is, instead of, yeah, let's be practical, don't have to type again and again. We'll just call this method magnitude, and this will return the square root, and that is the exact thing we need, and that's fine. Let's do this read only. All right, so now, so you can do this. Okay, like for example point.x. okay, and if I run this program, you can see the 5 is there, but if you try to x is equal 10, so you can see that the property or indexer point x cannot be assigned to it because it is in read only. So that was the point. So now as soon as you're creating an object of struct, basically the mathematical calculation is stored and it is gonna give you this exact result, like for example the magnitude here. Okay, now you can run, you see the result. If you wanna have the next, you'll have to create new object, and then you can type your next values and do this again. Instead of point, it will be point 1. See, we got 2 results here. All right, so I hope that's clear. So next we'll see how using generic to avoid boxing. We will see an advanced example here. So we are declaring iMovable interface with the generic type. Okay, and you can see that with the position struct we are implementing the iMovable, right? But while implementing, as you can see on line number 6, we are passing the generic type, that is position again. So this will avoid a boxing. And on line number 10 you can see that the implementation of move method. Okay, quick best practices here. So prefer struct for small immutable data types. As I told you, use for small operations, small, wherever you require small memory or small function, small, like I shown you a few mathematical calculations. Use struct. Avoid boxing by not using struct in interfaces based collections. Okay, and use read-only struct to prevent unintended modifications. Optimizing with generics to maintain the performance, as we saw in the last example, that we can optimize by passing the generic type, when implementing the interface. Use struct only when necessary to balance performance and memory. As I told you, you should be one who will be deciding that what we need to use and when. Okay, so awesome. Today we learned what struct is and why it's powerful, the difference between stack and heap memory, how to implement interface in struct, how to avoid boxing and improve performance, advanced optimization like read-only struct and generics. I hope this was helpful. If you enjoyed this video, make sure like this video, comment below with your questions, subscribe for more C# tutorials. Until next time, happy coding.